Hey, so apologies in advance if there's a lot of ums and ahs in this video. I'm going to try and focus more on spending time giving you all feedback. So if you need help, make sure to send me a message on Slack or to let me know that you want to set up a meeting for Zoom so that I can give you some feedback. So this video is going to be a little unpolished, but what I wanted to do was talk to you about pointers. So let's go ahead and get started. So one of the things that I wanted to kind of realize or have you all realize about pointers is that pointers, you guys end up seeing them all the time, right? You've all been familiar with certain errors that you've ended up getting. Sometimes you get blue screens of death or something like that. But a lot of the times you end up getting these errors that have this type of address that's being pointed on there, right? And so these normally are errors that involve particular pointers or locations in memory, right? A pointer is just a location in memory. And what I want you to realize also is that when you end up looking at this, for the most part looks like a number. Sure, there's an A and an F in here, but really this is the reason that those are in there is because this is using base 16 format. And so really I want you to think about the location and memory as being a number, okay? And that's going to be important because it's going to show you how I tend to think about pointers a little bit differently than maybe the way that you've been taught. And so to kind of get us started, I wanted to kind of show you in a way just this kind of area of memory, okay? And this is a fictitious area of memory. And I wanted to start off with just variables. If you remember, you can think of equals. You don't think of equals as being equality. You think about that as being storage, right? The fact that you're taking the value on the right-hand side and you're storing it into the value on the left. So in this case here, I'm just going to say that x has been allocated to this particular place in memory, right? That is at this particular memory address. And what we're doing there is we're putting in the value 10. Similarly, when we end up having something like this, you guys know that you end up taking the value x, right? The value of x, which is 10 in this case, and you end up storing it over into the value y. So that 10 now ends up appearing in y as well. And so similarly, that whole idea of numbers also applies to pointers. Here you kind of see, in addition to these two lines, that I've created 3 more lines here. With pointers, one thing that we end up doing is that we need to tell the computer, hey, you're dealing with a pointer. The way that that happens is that we end up including a star whenever we end up including a star whenever we end up declaring the type. So if you see a star and to the left of it is a type, you end up knowing that you're telling the computer, hey, this variable called a, I want you to know that it's a pointer to an integer. Okay? It is referencing a location which itself refers to an integer. And so in this case, what we're doing is we're taking this value x, right? And that value x, we're taking x and we're saying I want the address of where x is, okay? Which in this case is, with this, it's the same number but kind of has this 5, and I want you to go ahead and put that in the variable a, okay? And so the computer ends up reserving some other place in memory, and what it's doing is that it's putting that particular number as the value for a. So because we want to think of pointers as being numbers, what that means is that when we have something like a, I want you to think about it as a number, just like you ended up thinking of x as being 10 up here. And what it's going to do is it's going to take that number, right, that is in the variable a and essentially copy it into b. And that's what we have here. We have this number, which is 5A1115A, 1115, sorry, and then we're going to go ahead and put it or copy it into B. Notice that for the address of y, okay, which is at this, which ends in E over here, for the address of y, we're going to go ahead and take that address and store it into our variable c. And so that's why you could see that that has a different value or different location than the values that are in A and in B. Okay? And because they have these values, you can see that I'm also using this red arrow to kind of denote that, hey, this is the location of where this particular number is pointing to. And so in addition to having this address, one other thing that happens is that we have what's called dereferencing pointers, which I want you to think about as saying go to that address. Notice here that this has a different use than the use that's up here, right? Here, this is one of the confusing things about pointers, which is that this star, while we both use it and we both tend to think about it as being pointers, when we have a type that's to the left of it, it means we want to say that it's a pointer to an integer. However, when there's no type here and it's just the variable itself, we want to be able to say, I want you to go to the address of where a is pointing to. So here it's saying we have a pointer to an integer. Here we're saying go to that address, which is a little bit different. In this situation, if we were to see out a, we would just take the value that's inside of a. So we would hope that it would print out 5A1115. However, when we say, I want you to print out what the address is pointing to, what we would do is we would actually go to that address, 51A1115, which is here, and we would actually print out the value 10. And so that's how we would get two different values here. Similarly, when we move down here, notice that we can also store locations or numbers into A. I mean, really, this is kind of dangerous for us to do, and I would not recommend that you do this, but this is what some security experts sometimes end up doing, where they end up taking a pointer and they end up changing it to point to another number or another location in memory. So in this case, what I'm saying is I want you to go ahead and point it to 5A1111E, and that just represents another location. And so when I say star A equals 50, what that's going to do is that's going to actually, because we're saying that this is the location of where Y is, right? This is the location of where Y is, and we just kind of made up that number. That is now going to change to be 50. So just to kind of recap, I want you to make sure that whenever you see ampersand x and we're dealing with pointers, I want you to think of that as being the address of x, where x is a regular variable and the address of x stands for a pointer that points to a particular variable. The opposite is when we say something like star p and there's no type to the left. If there's no type to the left, I want you to think of this as being the value at the address in p, where p is the pointer, right? And star p actually is what goes to what is the regular value. And so what I'd like you to do is I'd like you to try and to go ahead and, like I said, pause the video right now so that you can end up seeing or trying to figure out what is the result of this problem that I'm giving you. And it's important that you do that so that way we can make sure that you're actively learning as you're going through this video. So if you can, go ahead and pause the video now. All right, so like I said, what is the final value of star P2? So you're trying to figure out what is, after this code runs, what is the value of star P2 here? And so what we're going to do is we're going to kind of start with these two variables. You end up having these two variables, and currently they're uninitialized, which means that they're kind of just pointing to random locations. The next thing that we do is when we have a new integer, I'm just going to end up saying, you know what, that new integer is a variable that ends up being created on the heap somewhere, and it has this particular address, right, which is a number, 521394. So 521394 is what actually gets stored into P1. Now, when I say something like star P1 equals 5, what that's going to do is that's going to go to the address of P1, right, and put the variable 5 in there. Now, for this next line, what we're doing is we're taking the value that's in P1, right, which is 521394, and just like we did with integers, we're copying that into the variable P2. And so that's why you see that it also has a copy of the same value that was in P1. Next up, when we do a dereference and we say go ahead and go take the value 8 and go ahead and store the value 8 into when you go to the address of P2, store it there. That's why we end up changing this value over here to be 8. Now, when I say make a new integer, that's now going to create a new integer over here on the heap with a new address, And that address, which is 52139A, is now what is going to be inside of P1. So now when we say star P1 equals 3, that's going to take the 3 and put it into the address that we talked about here. And so finally, if we ended up again doing something like saying P1, right, P2 equals P1, we're going to take the value of P1, which is 52139A, and we're going to go ahead and move it down in there. Okay? And so at this point, there is a little bit of a problem. And so the final value was 3, right? But there is a little bit of a problem, which is what happens with this A, with this 8 over here. Okay? What happens there? We don't have anything that points to it anymore, right? And so in a way, don't you feel bad about address 521394, right? Because no one points to it anymore, right? There is this terminology that we end up using where because no one is pointing to it, right, we say that that address is now orphaned. And so what we've done is we've effectively orphaned memory, which has led to a poor, sad bunny at address 521394. We want to make sure that we don't end up doing something like that, where we orphan a lot of memory. That's also what happens with memory leaks. You might have heard that terminology before, where if you end up leaving a program running for long enough, what ends up happening is that when you're running that program for a long time, it starts to consume a lot of the RAM on your computer. Partly that's because what's happening is that they're orphaning a lot of memory, which means that they're not deleting it and not saying that it still needs. They're saying that you don't need it anymore, right? You're not kind of referencing that. You're not saying, hey, this memory can be reclaimed. And because there's values in there, that tends to make our programs kind of bloat when we kind of run them for a really long time. And so the rest of the slides I'm just going to kind of put in here. Just want to make sure that you guys know that there's a new operator. The new can kind of be new integers. You saw that already. We have new doubles. We can also make new classes. Definitely make sure that you watch the Pointers with Binky video, which I ended up putting a link to in Canvas. In terms of arrays, one of the nice things is that with pointers, we can end up creating dynamic arrays, right? We do have this issue where if you wanted to write a program like this, where we said, let me go ahead and try and figure out what the length of a word is or get the size beforehand, writing something like this, we aren't able to do. You would end up getting a nice red squiggly down here that would say you are not able to do this. And so a way for us to be able to get around this is for us to use the new operator to be able to create a dynamic array. And this is what Lab 4 is going to be all about, is you creating new arrays that are dynamically allocated. In terms of accessing dynamic arrays, you can use two different types of notation. You can use array notation, which would work just like you would have with an array, or you can use pointer notation, where this same concept can be used by using this notation here, right? If you just follow kind of the syntax, you can see that the 2 also corresponds to the 2 here, but instead of using these brackets, we have this parentheses and we have this star, okay? We talked a little about deleting memory or cleaning, freeing up memory. The way to do that, if you're kind of done with a particular place in memory and no one's going to have access to it anymore, before you orphan it, you want to make sure that you delete it. If it's an array, you have this extra little piece of syntax when you declare a dynamic array, like we do here with P, we want to make sure that we use these array brackets so that way the computer knows how much memory it can reclaim and be able to use. There's also what are called segmentation faults. Once we start working with pointers, you start getting a lot of things where if you ended up having something be null and you try and go to a particular location that is not a good place for you to go, Visual Studio will be able to give you an exception, and so they can sometimes give you an access violation, right? If you try and dereference a particular pointer, and that pointer has a particular value, and that value ends up being protected memory or a protected location, you would get an access violation. last thing I want to kind of talk about real quick is that if you do end up having creating pointers to objects, say that you have something like this date. Here we have this variable called bday, which is a pointer to a date, right? We can end up using new and date, and then that would end up creating a new object on the heap. There's two ways for you to be able to access those the member functions. One way is to do a dereference on the pointer first and then use the dot, or the way that I actually prefer to use it is just by using the arrow. And so the kind of rule of thumb here is that if bday is a pointer, you use an arrow and then you can call the method, right? If date is not a pointer, then you go ahead and use the dot. And that's pretty much all the syntax that I have for you. So I hope that was okay. I hope that worked well for you. And if you have any questions, again, make sure that you message me on Slack so we can try and set up a Zoom meeting. I want to make sure that I spend most of my time in this class helping you out. And I think that that's time well spent. So good luck.